Okay, we are gonna talk about integration. Integration is actually anti-derivative. So we talked about derivative. Now we are gonna talk about integration at this video. See if you if you have 5x and you want to get the derivative of this, it's going to be 5. So integration is anti-derivative. So what we're going to do, if you have something like 5 dx, whatever the number is, 15x, if you want to find the derivative of that, it will be like this, 15x plus c. If you get the other the derivative of this is going to be 15. So this is the anti-derivative. Now, in general, if you have something like x to the power of n dx, what is going to be the integration is going to be x n plus 1 and n plus 1 here plus c in general. Okay, now if you find the integration of x to the power of 4 is going to be x, 4 plus 1 is going to be 4 plus 1 is going to be 5, and divided 4 plus 1 plus c, and it's going to be x to the power of 5 divided by 5 plus c. Okay, if you get the derivative of this, is going to be x4. 5 times x and 5 minus 1 divided by 5 times x to the power of x minus 1 is going to be the derivative of this one. Okay. So if you have something like x 3 plus 2x 2 plus x, what's going to be the derivative of this one, the integration of this one? So what you do, each of those is going to be each of those. Like we say x3 dx plus 2x, I suppose is put a minus here, plus and each of them has a minus x. So it's going to be x4 over 4 plus 2x3 over 3 minus x2 over 2. You know, if you add this one and then you put the exponent at the bottom. When you add this, x plus 1 and then the x plus 1 plus 1, this is going to be 1 actually. So 1 plus 1 is going to be 2 divided by 2, and then plus c. So it's going to be 1 for x4 plus 2/3 x3 minus x2 over 2 plus c. That's going to be the answer. Okay. If you have if you have another example, if you have something like integration of x no, let's use this one. What's going to be the integration of this one? We can write x to the power of 1 over 2 dx, and then x is 1 over 2 plus 1 divided 1 over 2 plus 1 plus c is going to be x 3 over 2, 1 plus 1.5 is going to be 1 plus half is going to be 1.5 is going to be 3 over 2, and this is going to be 3 over 2 plus c. So the result is going to be x to the power of 3 over 2 and 2 over 3 plus c. And you know that if you had something like this, you're going to write it like this. The power of this is going to be first at the top, so this is going to be 2 over 3 x 3, and the 2 we don't write the index of this one here, but it is 2 actually. So it's going to be this one plus c. Okay, this is not under radical, it's under plus. Okay, now what you're gonna do if you have something like this. If you have something like radical x 5 3, how do you dx? This is going to be dx always in front of it, because we are going to get the integration of this. So we can write it x. So you always write the power of this one at the top, and the index of this here, like this, plus dx, and this is going to be x 5 over 3 plus 1, 5 over 3 plus 1. We change it to this way, to the exponent form. We change it to the exponent form so we can get by the power rule, you know, we get the antiderivative of this. So this is what is going to be. This is going to be 5 3 plus 1, okay? So what is that? 5 over 3 plus 1, we can write it 1 as 3 over 3, right? And then the common denominator, 5 plus 3, is going to be 8 over 3. So that's going to be x to the 8 over 3, and 8 over 3 here. Is it 8? Okay. And then here you are going to have, these are going to be plus c. These are going to be plus c. Okay, this is, so that is going to be that is going to be like this, x to the power of 8 over 3. You can write it like this, 3 over 8 plus c. So that's the antiderivative of, the answer is this. So we change it to this form, okay? the power of this one is going to be at the top. The index of radical is going to be at the denominator. Okay. So let's solve more example. If this one was here, 1 over x, you know, I want you to learn this one too. That if we had like something like this is going to be minus 1 over 2, and minus 1. This is going to be plus 1 over 2. And this is going to be, see, minus 1 over 2 plus 1, we can write it as 2 over 2, you know, whatever the denominator is, we can write it 1 as 2 over 2. It's the same as 1, okay? And then minus 2 plus 1 is going to be 1 over 2. So this is going to be 1 over 2. And then the result is going to be, see, when you bring this one up, the sign of this, if this one was, is going to be x to the power of 2. But when you bring it up to the numerator, the sign is going to be changed. Okay, so so the result is going to be x to the power of 2, 1 over 2. 1 over 2, it's going to be 2 like this. You know, the division is going to be reversed. We reverse this one and put it up here, and this is going to be plus c. So that is the answer. So okay, we go to another example. If we have 3x minus 1, okay, what we are going to do? But we have something like this. Okay, it's better to write it like this: 3x minus 1 times 3x minus 1 and dx. And if you multiply this by each other, it's going to be 9x2 minus 3x plus 1. It's going to be 9x2 minus 6x plus 1. Okay? We can write it like this. So when you get the antiderivative of this, it's going to be 9x2 minus 6x plus 1 dx. Each of them is going to be, we get the antiderivative of each of them. This is going to be 9x3 over 3 minus 6x2 over 2. So we're going to add 1 and divide. This is going to be 1 plus 1 is 2, and divided by 2, and plus x plus c. So it's going to be 3x3 minus 3x2 plus x plus c. So that is going to be the answer. Okay. We can so there are some examples, more examples of this. How these are the technique. How do we use? Like we have x to the power of 3 plus 6x2 divided by x dx. Well, what you're going to do is you're going to write it like this: x3 over x plus 6x2 over x. You know, divide. You have to divide if you want to get the result. Each of those item here is going to be divided by the denominator, and write it like this: dx. Okay, when you get integration of this, first of all we simplify this one. Is going to be x2 plus 6x, okay, and dx. Then it's going to be the result is going to be x3 over 3 plus 6 x2 over 2 plus c. So the result is going to be 1/3 of x3 plus 3x2 plus c. Okay, this is going to be the result of this. So we divide each of those by those, each of these items by the denominator, and we write it like this, and we simplify. It's going to be 6 is x2. So we get x cancels out. x3 it means x times x times x, and x is good. So one of these is going to be x2. Oh, this one. And this one cancels out. It's going to be 6x, and then 6x is going to add 1 to this exponent, and divided that exponent by the same as we raised it. You know, 1 plus 1 is going to be 2 divided by 2. So that is another example. So these are the things, techniques that you can use to get the integration of that. How about if you have 1 over x3 dx? Here I can write it x to the power of minus 3, as we talked about it. And so what is going to be? X minus 3, the antiderivative is going to be, this is plus 1 minus 3 plus 1 plus c. So x is going to minus 3 plus 1 is going to be minus 2, and this is minus 2. C is going to be actually minus x to the power of 2 divided by 2, because this minus is going up here, plus c, and it's going to be minus x minus 2 over 2. So actually, when you have something like that, you can write it as 1 over 2 x to the power of 2 plus c. These are plus c. So we can write it in this form, because you can bring it down to denominator and write it like that. Okay. So there are some more examples here. So what we did, so we add this one to this. Minus 3 plus 1 is going to be minus 2, minus 2, minus 2 here, and then minus 2. We can write it this way. Okay, how about if you have something like that? 4x5 dx. You can write it like this: 4x to the power of minus 5 dx. Okay? And then it's going to be 4x to the power of minus 5 plus 1 divided minus 5 plus 1. This is multiplication, all this. Plus c. So it's going to be 4x to the power of minus 4 divided minus 4 plus c is going to be minus x to the power of minus 4 plus c, which is 1 over x to the power of 4 plus c. That is going to be That's going to be the answer. Okay. We write this one like this. The denominator is going to come up to numerator with the negative side, and then we add 1 to the exponent and divide the same exponent here. So it's going to be like that. So there is a how about if you have something like this, 1 over x dx? What's going to be the antiderivative of this one? The antiderivative of this one is going to be ln x plus c. So that is the answer. See, always the antiderivative or integral of dx is going to be ln x. 1 over x and x, the antiderivative of this one. Okay? You can. Okay, let me give some more examples. If we have something like 1 over x minus 2, what's going to be? So ln x minus 2 plus c. Okay, that's going to be the answer. Okay. Give you another example. If you have something like this, 5 divided x minus 3, how do you solve this? Okay, this is 5. You can write it behind this and say 1 over x minus 3 is going to dx. Okay, dx, then is going to be, this one is going to be 5 times ln x minus 3 plus c. Okay? How about if you have something like this, e to the power of 4x dx. The integration of this, integration of e to the power of x is going to be e to the power of x, because what you do, the coefficient of this one is going to be at the bottom, which is 1, you bring it 1 here, you don't write it, but it's like this. But if you have to the power of this, we can write it like this, e to the power of 4x divided by 4. The derivative of this one is going to be at the denominator, and this is going to be like this, 1 over 4ex to the power of 4x plus c. That's going to be the answer. Okay. So as we said, if you just have like dx, you write e to the power of x and bring the derivative of this one is going to come here, the derivative of this one is going to be 1. Okay? And then write it like this. But whatever it is, whatever it is, 5x2 plus x. If we had like this, what we're gonna do? Okay, we are gonna write e 5x2 plus x divided by the derivative of this of 10x plus 1. Let's see, this is gonna be the answer. You get the derivative of that one and write it at the bottom, and we write it like this. So it's you always get the derivative of this one right at the bottom, and that's gonna be the answer. Okay, now I'll give you another example. Like we have 6 times x to the power of 3x dx. Well, how we are going to do this? Okay, we say that we write 6 e to the power of 3x and then divided by 3, okay, plus c. It's going to be 2e 3 to the power of x plus c. So it's going to be 2e to the power of 3x plus c. Okay? So when you have something like this, you get this one goes behind, it can go behind this integration, and then you do the integration itself. You know, you can see, say, e to the power of x dx, and then 6 is going to be times 3 to the power of 6 divided by 3 plus c. Then we divide this one, is going to be 2. 6 over 3 is going to be 2. Okay. We I think we have time to solve one more. It's going to be, whatever it is, 12e to the power of 4x. What is going to be dx? What's going to be the result? We write 12 e to the power e 4x dx, then it's going to be 12 e to the power of 4x divided by 4 plus c. Okay, and then the result, it's going to be 12 over 4 is going to be 3e to the power of 4x plus c. That's going to be the answer. So these are some of the techniques that you can use to find the antiderivative or integration of this. Thank you very much for watching.